All right. So, Advent of Code 2015, day 3. Let's get started. I think it's a nice one. It's called Perfectly Spherical Houses in a Vacuum. Santa is delivering present to an infinity two-dimensional grid of houses. So we have a grid of houses. It's two-dimensional. He begins by delivering present to the house at the starting location. So we have a starting location, and then the elves on the North Pole call him via radio and tell him where to move next. So he move north or south, east, and west. Okay, so we have four directions. After each move, he delivers another present to the house on his new location. Okay, so we deliver the present in the current location and then the next location and so on. However, the elf back in the North Pole had a little much to eggnog. I think this is some kind of drink the elves drink there. It's nice. I think they were drunk. And his direction is a little bit off, and the Santa ends up visiting some houses more than once. How many houses receives at least one present? Okay, so it looks straightforward. So let's see. So if we have only one move to the right, for example, we have visited two houses, one at the starting location, one at the east. And if we have like north, east, down, and then west, we have four houses. Okay, so let's try to visualize it a bit. So so let's try to visualize it. Okay, so what we have is two-dimensional grid. Okay, so this is a grid, and we have a starting location. So the starting location anywhere. So let's see this starting location. So the starting location is supposed to be the point where it's 0 and 0. And when the Santa is moving to only one direction, so we have a present in the position 0, 0, and then we have a present at the new location. So the new location, since we are in a two-dimensional grid, so when we go to the right, we increase the x's, and then when we go to the left, we do decrease the x's one, and then when we go up or to the north, we increase the y, and then when we go south, um, we just do decrease the y where we are at the two-dimensional grid. Okay, so let's have another example. So they have another example, which is going up, then left, then south. Okay, so let's try to visualize it. So this is our two-dimensional grid. Okay, so it's enough. We start with this location. So theoretically, we have the start location. We have a present now. So in 0, 0, and then we move up. So we said when we move up, we increase the y. So the point is x and y. So it's in the new location. It's 0, 1. Then we move to the left. So when we move to the left, we increase the x-axis. So it's the new location. It's 1, 1, and then we go down. So we are in the new location. It's 1, 0, and then we go back. It's 0, 0. So if we counted how many houses we have visited, we see that we have visited like 1, 2, 3, 4, 5 houses. So according to the one, it's correct because we did 5 moves, but this one we have the house got two presents, so it's one. It's counted as a one. So 1, 2, 3, 4. So actually, it's only four as counted. Okay, so let's dive in the code. I think it's straightforward in the code. This is from yesterday. Okay, so what we need now, we need to create a new directory for the third day, and then we need to create a new files. Okay, so it's for the day, and okay, so it's a package day 3. We have a function solve, which receiving the input and from string and doesn't have anything. Okay, so this is the first one, and as we said, we are going to present the each house or each house location as a two-dimensional grid, so we need a point. So what we use yesterday, we use a type, we have a from point struct, and then we have x and y from int. Okay, so this is the first one. Okay, so let's what's the next step? We need to uh, okay, so I'm checking here, so we need to parse this from input. Okay, so what we need to do to create a move function, so move from a single point to the next one, which is parsing the new position in the grid. So what we can use function uh, point and then move okay, so to the direction, and then in in Go we have a string and we have a rune called rune. It's similar to character or char in other programming language, so it's type rune. And then when we move to a point, we have also another point, so also the output is a new point. So this is would be very straightforward with the switch the direction, and in case the direction is up, we just we return new point. The new point has the x's of the previous one and has the y's added by 1, and then in case we are going left, we return point, but the new point has x's increased by 1 and has the same y in the origin point. And if we went down, I think it's v, yeah, it's v, return also point, but when we go down, we have to decrease, we have the same x-axis, and then we decrease y-axis by 1, and then in case we have going to the left, so what we do, we return the point with the same with x-axis -1, and then p the y-axis. Okay, it's p small p then y, and it's also here small p. Okay, so if nothing matches and we don't have this case, we just return the single point, so it's moving to the same point. Now what we need to do, we need to have a list of the visited houses. So the puzzle says how many houses receive at least one present. So in our example, the first one received 2, so we didn't count it for the second time, so it's 4. So the best option to store it, we can store it in a map or in a hash map in Go. So let's start it. Function find houses visited houses, just visited houses, and then the input is the same as a string that we receive, and it has a integer, the number of houses as an output. Okay, so in Go we create the map in a very easy way. So let's have visited, and we need to use the function make, and then we have the map. So the map is a hash map, and it has a key and value. So the key has a different type or the same type of the value. And for our example for the day 3, we need the input as the type of the key is a point, and the type of the value is, we can use it as a boolean, so it's correct. Okay, so we have the point or the position. So let's go to Santa position. At first, Santa is in the first position, so it's in 0 0. So this is one, and then we have to go to each character or to each rune in the string and then move to the next position. So we use the range and we don't care about the index, character, or dir. And then what we do, range, we can use range input, input, and okay, so simply visited, visited. We need the move the point. So okay, so first position is always visited, so we need to add it. So visited Santa point equals true, and then we need to move it. So Santa point, Santa position, um, Santa position dot move, where we have to move it to the new direction or to the new run, and then we put visited Santa position true. Okay, so I think this is very simple. Hopefully it's correct. Return to count the number of entities in a map. In Go we can use simply length and visited, and let's see. So here visited, visited, visit houses from input, let's say. Okay, so print part 1 visited houses. We need a digit and then or decimal. So yes, so it's let's try to test it. So we need to test it with a single one. Okay, so here the our input, go run main day 3. It's not, we need to add it. So we need to go to the main file and we need to add the day 3. So this is day 3, and then we have to add it to the implementation here to execute it. And here is day 3, day 3. So now it's a pause. Okay, so visit to house, it's correct. Let's try it with another example. So this is the second example. So we have this one. Let's try it. Okay, it's for houses, it's correct. And the third one, okay, it's correct. So now let's solve the actual puzzle. So the actual puzzle is, let's get the input and go, let's go see recording. Okay, this is day 3, 2572. Let's try it. It's 2572. Nice, we got 1 star. Okay, so let's see the second part. The second part, so the next year, to speed up the process, Santa creates a robo version of himself, Robo Santa. So now we have a Santa and Robo Santa. So both of them, they start at the same location, delivering present to 2 at the same house starting. Okay, so the first house received 2 gifts. Okay, from Santa and Robo Santa. Then it takes turn moving based on the instruction from the elves. Okay. Okay. So the example. So for if it goes up and down. So this is level 3 present, one for the first house and one for the second house. So Santa goes north and Robo goes south. Okay, and the second one, Santa goes up, Robo goes to the left, to the right, and then goes down. Okay, so each one of them goes in a separate direction. So the first instruction, the first the first thing, both of them is the same as a starting location. Then Santa goes up, and then Ropo Santa goes down, and then one by one they swap the position or the delivery of the message. So let's try it. I think it's supposed to be the same. So I will just copy the function exactly the same with adding the Santa. So if both of them they are visiting the same houses and they are alternate between Santa and Ropo Santa, what we need to do to have different starting positions for Santa and Ropo Santa. So we can have Robo position, maybe also start from 0. And since we need to all the houses that receive at least one present, so we need to share the visited houses. So first one visited Santa is true, and then I think this is not needed to robo position true because it's the same position. um, but let's go. So for this one, we need to change it because for Santa goes to 0, 2, 4, and 6. And for the Robo Santa goes to 1, 3, 5, and 7. So, okay, so we need to use the modulo and the index. So we need to get the index. Here's the index, center position. Okay, so we care about the center position and only if it's even. So center even and robo. Let's go with center goes on even and robo goes. Okay, 1, 2, 3. So if index modulo 2 0, then this is Santa, so we need the Santa position. We can get these ones, go here. Okay, nice. And then if index not, or we can just choose else. I think we just else robo position for robo position that move to the new direction and then visited. Okay, and then visited rob visited visited. I think I have a typo. Robo Santa equals true. So this is not visit, this is visited. Visited, okay. Okay. So it's corrected. Robo position, and then we retain the positions. Okay, so let's try it with let's try actually the correct solution for now. If it's correct, let's just return it. So this one, and then we have RoboSanta 2 and visited 2 part 2, not inventing any new names, just keep it simple. Visited 2, why it's not working? We kept the function the same name, I think. Visited houses 2, it's correct what's happening. uh, Visited 2. Okay, what's wrong? Okay, Oh, I can't see it. Okay, so just extra parentheses. Let's run it. Day 3. Okay, part 2, part 1, part 2 slash n. This is when you just hit record and start talking. You will have so many problems. Okay, so it's 2631. Let's try it. 2631. Oh, nice. So now we are fully took 2 stars. I think today's video was easy. Um, I have some typos, but it's okay. We learn to use map, so we check the map and we add items to the map, and then we solve the problem. It's straightforward. And see you tomorrow in day 4. Bye.